Something strange is happening to Betelgeuse, and astronomers are worried. The red supergiant star in the constellation Orion is suddenly shining 50 times brighter than usual. Excitement broke out among astronomers. Is this the supernova signal everyone has been waiting for? And is the red supergiant's explosion now imminent? Come along on a journey full of answers to these pressing questions and be surprised by what Betelgeuse really is. Betelgeuse is about to collapse. Betelgeuse is a bright red spot in the night sky. On its prominent position in the shoulder of Orion, it is the 10th brightest object in the night sky after the Moon, the planets Jupiter, Venus, and Mars, and some other stars. Betelgeuse will soon disappear, that much is clear. The star, which was probably there for billions of years, will outshine the whole galaxy in a final explosion and then collapse. All that will be left behind will be a neutron star or a black hole. The explosion will be an event of epic proportions, and at only about 650 light-years away, we humans are ideally positioned to observe this cosmic spectacle up close. Still, we are far enough away to be out of the direct danger zone. When the stellar explosion occurs, it will bring an incredible spectacle of light across the galaxy. The first sign of the imminent collapse would be a sudden flood of neutrinos that would swamp the Earth and can be detected by observatories worldwide. Shortly thereafter, high-energy photons would escape from the debris cloud, and Betelgeuse's final light would be up to 100,000 times brighter than we see it now. The actual explosion will exceed the brightness of the full moon at night, and even during the day, a bright light would be visible for a few seconds. After that, a supernova will shine brightly in the night sky for several weeks to months. Betelgeuse will be among the brightest objects during this time and will be an unusual sight for us humans. For astronomers, this will be an opportunity for detailed study, as it only occurs every few hundred or thousand years. Betelgeuse shows suspicious signs. Already, the red giant Betelgeuse is so large that it would reach as far as Jupiter's orbit when placed in our solar system. Late in 2019, the aging star began exhibiting strange behavior. The red supergiant mysteriously began to dim. Even with the naked eye, observant people could see the star flicker. This kind of dimming had never been observed on the star before. Images of the star taken in the optical spectrum with the Very Large Telescope initially still showed an approximate symmetry in luminosity. However, scientists then found the first signs of a large shock in the photospheric layers. Was this a signal that the star's final hour had dawned? The photosphere is the outer shell of the star that emits light into the cosmos, and this very edge had suddenly begun to expand enormously. It almost seemed as if the final scenario was about to begin. Briefly, the star swelled at a constant rate of about 8 kilometers per second. In mid-November 2019, the expansion stopped again, and astronomers held their breath. Will there be an explosion or not? Nope, at least not in 2019. Betelgeuse held this inflated state for a while, and researchers took the opportunity to take a close look at the new situation. Images of the anomaly showed that a dark southern hemisphere had appeared on the star, for which there was no explanation. The only thing that was certain was that Betelgeuse's face had changed extremely compared to an image taken in early 2019. Because Betelgeuse's surface can be directly observed from Earth, the star allows for particularly intense studies. Even amateur astronomers can track the star's flickering with simple telescopes. Further, the scientists noted a dip in the star's surface temperature. It had dropped by about 80 Kelvin. Researchers were still trying to understand these strange events when it happened again, and Betelgeuse's brightness suddenly decreased dramatically. Between January 27th and February 13th, 2020, it reached a historic low. This condition also lasted a few weeks. Then the star began to brighten again and shrink back to its normal size. Scientists were baffled. It seemed as if the red supergiant had led them a bit by the nose. But what really happened to Betelgeuse? A gigantic mass ejection. It took weeks until all data showed a coherent picture. Then all the evidence pointed to Betelgeuse having experienced an enormous surface mass ejection. Something similar is happening on our sun, but on a much smaller scale. We call this phenomenon a coronal mass ejection, or CME. Because scientists have never observed the event on a supergiant, the phenomenon was given the name SME. SME stands for surface mass ejection, while CME stands for coronal mass ejection. In these events, our Sun or any other ordinary star suddenly ejects a significant amount of its mass from its surface. But Betelgeuse is no ordinary star. With him, everything happens in somewhat larger dimensions. It's a bit as if the aging star had a brute coughing fit. You can also imagine a superlative volcanic eruption. A large amount of material from inside the star moves upward, creating shock waves in the star's atmosphere. The material formed lots of molecules and dust that partially blocked our view of the star, making it appear darker. In the dimensions of Betelgeuse, this event was of course a bit bigger, and so 400 billion times more mass reached Betelgeuse's surface with the ejection than is the case with the biggest mass ejections of our Sun. The material was ejected with incredible speed. For researchers worldwide, this was the largest mass ejection they had ever seen on the surface of a star. The events and all the surface details were observed with Hubble, the old space telescope. At that time, James Webb had yet to be launched, but even Hubble was able to take impressive images of the SME. For Betelgeuse, it was not without consequences. The SME had a strong impact on the star. It lost a considerable amount of mass in one go. This proved that, in comparison, a dying star can lose further substantial mass from ejections like this, in addition to its annual mass loss from stellar wind. Scientists were not even aware until this point that stars in their final stages are also capable of mass ejections. Since then, of course, it has been watched with excitement to see how the scenario continues to unfold. Betelgeuse had a wound at the place of the ejection, and as it happens in old age, the giant star recovers only slowly from the injury. Since the ejection, Betelgeuse's brightness pattern changed in an interesting way. It was known for a long time that the red giant begins to pulsate every 400 days. Now this rate is every 200 days, and again, scientists draw the comparison with an old human being weakened by the ejection. In the dry technical language of astronomers, Betelgeuse is now formally a semi-regular variable star. What this exactly means is that it shows several cycles of increasing and decreasing brightness, which can be traced back to changes in its size and temperature, and within these patterns shows changes like the SME. Mysterious pulsation. In addition to its former 400-day pulsation rhythm, Betelgeuse has another linear light show that occurs about every 5.6 years. The origin of these brightness changes is as yet unknown. Computer simulations showed that unusually hot gas flows from its interior may be responsible for the 5.6-year rhythm. These types of hot gas bubbles occasionally occur in the star's turbulent, convective envelope, and we might liken this phenomenon somewhat to a boiling pot of soup. Material is constantly moving and mixing and being swirled around. As this hot bubble rose and erupted from the surface, it caused the ejection of the star's material. Betelgeuse will likely continue to change its pulsation in the future. The new short 200-day cycle will most likely give within 5 to 10 years, and then the red star will flicker, as in its usual 400-day pulse. Or else, Betelgeuse will explode. Still in an early stage. Scientists have to admit that they cannot know everything about a dying star. Much is still unknown, and events of this kind are so rare that even our best scientists currently have only fragmentary knowledge and can only guess. Based on the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is still in an early stage of decay. It may be going through the helium to carbon fusion phase, in which the elements inside the star are changing. Instead of light gases, more and more oxygen, silicon, and eventually even iron are formed. The weight of the star increases as a result, and at the same time, it becomes more and more powerless, and eventually the weight becomes so great that the core of the star collapses under its own weight and explodes. Since Betelgeuse is 650 light-years away, any supernova event that occurs now would not be visible to us for 650 years because of the speed of light. So, It could be that Betelgeuse has already exploded, and we will see the event soon. But then, the star would have already exploded 650 years ago, which was in 1373, and at a time when the Plague and the 100 Years' War was raging in Europe. If the star explodes now or in 10 years, the light will be on its way to us for 650 years, and you and I will not be able to witness the event. Does a supernova bring bad luck? In the past, people on Earth observed supernovae several times. In 1604, the German astronomer Kepler witnessed a supernova, and around 1000 AD, Chinese astronomers saw a bright supernova in the constellation of Taurus. They had mistakenly assumed that the new glaring object in the sky must be a new star. At the same time, misfortunes, strange natural events, and disputes associated with the unusual cosmic event were occurring around the world. As far as renowned natural science is concerned, we are fortunately at a safe distance from any harmful effects. Nevertheless, elevated neutrino storms and gravitational waves are expected on our Earth for a long time after the Big Bang. Even in the vastness of space, everything comes to an end at some point. And yet, an end can also be a new beginning. As soon as a massive star bids farewell to the cosmic stage in an explosive supernova, it leaves behind a neutron star in a hot, ionized gas nebula, and thus an object that is one of the most extreme celestial bodies of all. Although the stellar remnants, which essentially consist of neutrons, usually have more mass than our Sun, they are often only a few kilometers in size. As a result, compact stellar remnants are the densest objects in the cosmos after black holes. But that's not all. In addition, neutron stars also have the property of retaining the angular momentum of the original star and also compressing its magnetic field within themselves. However, due to their compactness, the rotation of the neutron star accelerates so much that from then on, it no longer takes several days for it to rotate around its own axis, but only seconds or fractions of a second. And while all pulsars are neutron stars, not all neutron stars are automatically pulsars. These are characterized by the fact that they emit their radiation in a narrow beam, just like a cosmic lighthouse. As soon as this beam of radiation sweeps across the Earth, it can be registered due to the rotation of the pulsar as a regular pulse of radiation, hence the name. So far, so familiar. But now, a research team led by astrophysicist Manisha Caleb from the University of Sydney has identified a pulsar that can confidently be described as a snail with a limp. And yet, it makes the impossible possible. More specifically, this refers to the fact that the object emits radio waves even though it shouldn't be able to do so. In this regard, the theory says that a neutron star that completes less than 1 revolution per minute is simply not capable of this, but the newly discovered stellar remnant estimates a whopping 6.5 hours for 1 rotation. An object that shouldn't exist? Traced with the help of the ASCAP radio telescope in Western Australia and given the scientific name ASCAP J1839-0756, the peculiar celestial body is thus pushing our understanding of pulsars to its limits. However, the mere identification of the object did not pose a major challenge for the experts. After all, no one celestial body had ever been detected at the corresponding position before. The radio emission detected during a routine observation presented itself to the experts as a decaying burst, whose brightness dropped by 95% in just 15 minutes. However, at that time, astronomers did not yet know that the corresponding source emits periodic radio pulses. After all, only a single burst had been registered during the first observation. In order to shed more light on the cosmic darkness, the researchers relied not only on further observations with ASCAP, but also on the Australia Telescope Compact Array and the Meerkat Radio Telescope in South Africa. In the course of this, 2 radiation pulses were to be documented at intervals of 6.5 hours. On the one hand, this was accompanied by the realization that the source has a periodic nature, and on the other hand, that the object should not actually exist in this form. Neutron stars basically emit radio pulses by converting their rotational energy into radiation. Over time, however, they lose energy and slow down. An established theory says that a neutron star should stop emitting radio pulses at a certain point, that is, at about 1 revolution per minute. And yet, the peculiar pulsar that illuminates the cosmos at a very leisurely pace of 1 rotation in 6.5 hours is there. Most pulsars, which rotate at a significantly higher speed, are like flashlights that only shine from one side. That's to say, the axis around which they rotate is closely aligned with the axis of their magnetic field, so we can only observe the bursts from one magnetic pole. But in around 3% of all pulsars, and this is the exciting thing, the rotation and magnetic axes are almost at right angles to each other, which means that we can see the bursts from both poles. These rare double flashes, which experts call interpulses, thus provide us with a unique insight into the geometry and magnetic field of the celestial body. Whether the magnetic and rotational axes of a slowing pulsar become more or less aligned is, however, an open research question, but the interpulse of the newly discovered object could help us to crack this mystery. In fact, the pulsar emits another, weaker pulse about 3.2 hours after its main pulse, but with different properties. According to the experts, this strongly suggests that we are dealing here with the radio emission from the opposite magnetic pole. This fact also makes the celestial body the first known Snell pulsar to emit such intermediate pulses, although this only serves to deepen the questions about its origin. How can the impossible be explained? But what do the experts have to say about this cosmic anomaly? Is there any approach that can explain the supposedly impossible in a comprehensible way? Well, yes, there is, but it's complicated. But first things first, the first theory is based on the assumption that the object represents a magnetar. We could therefore be dealing with a special form of pulsar that is characterized by an extremely intense magnetic field. Specifically, the magnetic field of a magnetar is about 1,000 times stronger than that of a normal neutron star, and in addition, they generate their radio pulses by a different mechanism that could perhaps enable them to continue radiating even at lower rotation speeds. But even magnetars have their limits, and their periods are usually measured in seconds, not in several hours. But even in the field of astronomy, exceptions sometimes confirm the rule. And in this case, the exception has the scientific name 1E 161-348-5055 and describes a magnetar that has a rotation period of 6.67 hours and actually emits radiation, but it's X-ray radiation, not radio pulses. In light of this, some researchers believe it's more likely that the unexplained stellar remnant does not in fact represent a magnetar, and furthermore, not even a neutron star. Instead, according to the alternative hypothesis, it could be a white dwarf, and thus a small, very compact old star. More specifically, white dwarfs are the hot cores of red giants that remain when they shed their outer shells. And indeed, white dwarfs rotate much more slowly than neutron stars, and yet no single, isolated representative of these celestial bodies has been observed to emit radio pulses. This is compounded by the fact that studies in other wavelength ranges have so far provided no evidence for the existence of a white dwarf at the celestial location in question. And so it turns out that as things stand, only one thing can be said with absolute certainty about the background of the strangely slow object. It is a full-blown mystery that has left experts scratching their heads, because no matter what the celestial body ultimately turns out to be, it will rewrite at least part of our astronomical rulebook. The strange combination of slow rotation, radio pulses, and intermediate pulses is forcing researchers to rethink the characteristics of neutron stars. And it reminds us once again that the universe still has many exciting surprises in store. This applies not only to the cosmos's most leisurely outgrowths, but also to the opposite end of the speed spectrum. In fact, it wasn't that long ago that astronomers also found a record-breakingly fast neutron star that spins over 40,000 times around its own axis within a single minute. The Speedy Gonzales of stellar remnants. Better safe than sorry. Neutron stars, due to their enormous gravity, sometimes come in double systems, where they often siphon off huge amounts of material from their stellar partners. Since this often results in periodic bursts of high-energy X-rays, experts also refer to such neutron star partner pairs as X-ray binaries. And now one of these X-ray binaries has underlined its record-breaking ambitions in two ways. Located around 26,000 light-years away from us and christened 4U 1820-30, the duo is composed of a neutron star that is only 12 to 16 kilometers in size, but weighs 1.4 solar masses, and a white dwarf that is about the size of Earth, but significantly less massive. To find out more about the strikingly small pair, Gaurava Jaiswal's team at the Technical University of Denmark spent 5 years scrutinizing it using the NICER X-ray telescope on board the ISS, and in the process, they uncovered some huge surprises. In principle, the so-called oscillations, or in other words, the slight, rapid fluctuations in X-ray intensity that occur during the radiation bursts, can provide us with fundamental information about the speed of a neutron star's rotation. And in the case of the binary star in question, the oscillations showed that the neutron star rotates an outstanding 716 times on its own axis. And that's per second, mind you. In other words, the object makes a whopping 42,960 revolutions in 1 minute, which could make it no less than the fastest known neutron star ever. So far, this title still goes to the pulsar PSR J1748-446, which also makes 716 rotations per second. However, further follow-up observations are needed before the speed record is officially shared. But the second component of the binary system also seems to be setting new astronomical standards. Specifically, the white dwarf takes only 11.4 minutes to complete one revolution around the neutron star. However, the rapid orbits come at a price. Since the stellar remnants are very close together, the neutron star can extract a particularly large amount of helium from its partner. This helium then accumulates on the surface of the neutron star before its density exceeds a certain threshold, and finally sets off a thermonuclear explosion. In the course of these eruptions, the neutron star shines up to 100 times brighter than the Sun, and its surface inflates by around 50 kilometers. Voyager 1 is a marvel of technology and an achievement of human engineering. The probe, which was launched in 1977, has since studied numerous planets, moons, and many other phenomena and features. It has traveled around 22 billion kilometers, and Voyager 1 is still communicating with Earth. In November 2023, things got dicey. Voyager 1 suddenly sent nothing but garbage data, and panic broke out at NASA. Had the longest traveled probe of all time given up the ghost prematurely? For a long time, it really did look as if Voyager 1 was lost forever this time. Researchers had secretly hoped to be able to operate the probe until 2040. Its energy supply could actually last that long, but nobody knows how long the radio link can be maintained over such enormous distances. Voyager 1 is of inestimable value to science because the probe is located where no man-made object has ever been before, in interstellar space. This hitherto largely unknown medium between the stars forms the largest expanse of the universe. The space between the individual star systems is incredibly large, and in this mysterious space, researchers suspect many answers to previously unsolved questions about the true nature of the universe. What do all the cryptic data from 1 and 0 mean? For 5 months, Voyager 1 sent only cryptic data. Endless loops of 1 and 0 reached NASA's control center. The probe was clearly still alive. The data stream was unbroken, but the transmitted messages were suddenly incomprehensible and therefore useless to scientists. Even the best decoding machines and human experts initially struggled to decode the messages. Then, an employee of the Deep Space Network, which supports the communication of the 2 Voyager probes, found the solution. Voyager 1 had sent a complete imprint of its memory system, only it was encrypted in a very special way. Many months passed, and NASA's hopes of being able to put the probe back into operation properly faded. This feat had already been achieved once before in 2021, when a telemetry problem had also resulted in unusable data. In early spring 2024, NASA's press officer had already announced that they were preparing to lose Voyager 1 forever. But then, the probe started transmitting again. Since the beginning of April 2024, we have usable data again, and the Voyager adventure can continue. What was that? Mysterious data from the universe? Can you imagine what it's like to listen into the depths of the universe every day? Every day, there can be a crazy surprise. The NASA employees monitoring Voyager's flight receive measurement data from the probe around the clock. Most of the instruments, and especially the cameras, have been switched off for a long time. At present, Voyager 1 only measures the density of the plasma and the strength of the magnetic field. This is perfectly adequate in the interstellar medium. It is so dark here that images would make no sense, and the only things that count for the scientists now are particle currents and radiation. Imagine the data as permanent noise, with fluctuations appearing here and there, signals from particles or plasma. It must be highly peculiar when a signal suddenly appears in this monotonous silence of the universe, astonishing everyone. It was like a mysterious cry when Voyager 1 suddenly reported a remarkably dense stream of particles or plasma. The unusual intensity of the signals indicated a completely new phenomenon. The signal seemed to the researchers as if a lively bubbling source of something unknown had suddenly appeared in a desert. At first, NASA was at a loss. What could it be? The researchers were in for a big surprise as soon as they entered the interstellar medium. Voyager 1 measured a much higher particle density than expected. In interstellar space, the density of particles drops dramatically compared to the interior of our solar system. With its permanent plasma flows, our sun forms a protective shell around itself and all its planets. Scientists call this shell the heliosphere. Where there are around 100 particles per surface within the heliosphere, there is probably only one particle in the space between the stars. Although the particle density fell as expected in the free universe, there were far more particles present than the calculations had shown. This initially means that the interstellar medium is denser than we thought. From a physical point of view, a few particles can have a huge impact. We have to wait and see what this hitherto largely unknown medium will bring us. This is precisely why the Voyager probes are of such great value to our science. The strange stream of particles measured by Voyager 1 in 2023 seem to upset this picture once again. A stream of this intensity could be some kind of interstellar flare. But if so, what was the source? Voyager 1 is very far out in space, and yet in cosmic terms, the probe has only just flown out of our solar system. If we were to place Voyager 1 on Earth in Berlin, the nearest star would be, to scale, in Beijing. And between these two cities, there would be simply a vast expanse of nothingness. It is unlikely that a stellar flare would travel that far through space. What other sources are possible for this strange signal from the universe? Theories abound, with some suggesting it could be traces of a previously unknown force, and some scientists even speculating that it could be an alien intelligence's response to Voyager 1's signals. What happened to Voyager 2? Voyager 1 did not launch alone. That is common knowledge. But what is less well known is the fact that Voyager 2 followed a completely different trajectory to its twin. Voyager 2 was the first of the two space heroes to launch in 1977, but it was the second to arrive at the outer planets. This was because Voyager 2 maneuvered very differently from Voyager 1. In the 1970s, scientists used the two probes to try out different techniques of acceleration, flyby maneuvers, and navigation. Although both probes are technically exactly the same, the routes they were sent on differed significantly. Voyager 1 took a more direct and dangerous course through the asteroid belt between Mars and Jupiter, while Voyager 2 was accelerated by many flyby maneuvers at various planets. Both reached their destinations and sent us unforgettable images of the outer planets and moons. We have the two probes to thank for the first real moving images of Jupiter. For the first time, researchers are excited to see the moving surface of the gas giant. Voyager 1 also gave us the first images of the Great Red Spot, and since its mission, we know that this striking feature of Jupiter is also a storm in constant motion. Voyager 1 also photographed Jupiter's moons Io, Callisto, and Ganymede. The probe observed an active volcano on Io, proving that there is geological activity on other celestial bodies. Voyager 2 provided us with more detailed images, For the first time, it photographed Jupiter in true color, and humanity was amazed at the beautiful brownish marbling of the planet. Once again, this probe provided us with breathtaking images of the fascinating moons of the outer solar system. After exploring Saturn, Voyager 1 and 2 parted ways again. While Voyager 2 was the first probe to reach the planets Uranus and Neptune, Voyager 1 was already on its way to the outer regions of the solar system. Voyager 2 followed it after completing its primary mission, and both probes successfully crossed the heliosphere many years later. Nobody really expected this in 1977. The fact that these brave heroes of space exploration would still be flying and sending data so many decades after their launch was nothing short of a miracle. Today, Voyager 2 is also quite far out in the interstellar medium. In July 2023, unfortunately, there were also serious problems with Voyager 2. NASA was once again trembling and eagerly searching for a solution. Once again, the engineers achieved the unbelievable and brought the probe back into its regular orbit over a distance of more than 18 billion kilometers. Since August 2023, Voyager 2 has been sending data back to Earth as usual. Today, a signal needs more than 22 hours to cover the one-way distance. The radio transmission over this enormous distance is another miracle of this mission. The data is transmitted by the antennas of the two probes. These antennas are always pointed towards the Earth. 3 large receivers, located in California, Spain, and Australia, capture the signals and forward them to NASA's control center in Pasadena. The Deep Space Network is a global communications system that oversees many interplanetary research missions and space communications. A journey that lasts forever? NASA is now optimistic again. The technicians have now been through so many adventures with the Voyager probes that they hope to be able to operate them for a few more valuable years. The Voyager probes use radioisotope thermoelectric generators to generate energy. These generators are based on the heat generated by the decay of plutonium-238. As the plutonium decays extremely slowly, their energy supply has been secure for decades. However, this ingenious technology is slowly coming to an end. Scientists hope that the electricity will last at least until the mid-2030s. Even if contact is broken off one day, the mission will still continue. The Voyagers are virtually indestructible and will still be flying through space thousands of years from now. In the event that the two are one day found by an alien species, they each have a golden record on board that can be played by any halfway technologized society with simple instructions. This galaxy has already shown us in an impressive way that it's not what we think it is. In the 1920s, big names like Harlow Shapley, Heber Curtis, and Edwin Hubble conducted research using the latest technologies of the time. Thanks to the achievements of electrical engineering, telescope performance increased significantly in the early 1920s, and for the first time, astronomers were able to look beyond the edges of our galaxy. At that time, Heber Curtis was still one of the researchers who believed that the Milky Way was the entire universe. His colleague Harlow Shapley, however, already suspected that there were other galaxies and that the universe was much larger. Shapley and Hubble had spotted strange nebulous clouds behind the border of the Milky Way. One of them was named the Andromeda Nebula because it hides behind the constellation of Andromeda. At the time, Andromeda was initially regarded by the general scientific community as a simple nebula that was virtually outside the actual universe. In 1924, Hubble then achieved a revolutionary breakthrough and was able to prove that Andromeda and several other nebulae discovered were in fact galaxies. That's crazy, isn't it? That was just 100 years ago. So, for 100 years we have known about other galaxies and the true nature of Andromeda. Back then, people got their first impression that the universe was even bigger than they had previously imagined. We have experienced such upheavals again and again in our history. People used to think that the Earth was all there was and that the sun was a hole in the sky through which light from a god shone onto the Earth. Then people thought that the Earth was a disk and that you would fall into nothingness or hell if you went beyond the edge. Galileo Galilei was put under house arrest in the 17th century for his claim that the Earth revolved around the Sun, and a few centuries later, the Church finally recognized that the Earth was round. Can you imagine what Galileo would have said about such images, or how the Church of the Middle Ages would have reacted to the idea of galaxies in an almost infinitely large universe? A galaxy twice the size of our Milky Way and with trillions of stars. Around 100 years ago, Andromeda turned out to be not only a galaxy, but also a collection of stars far larger and more powerful than our own. Initially, astronomers thought the galaxy was a disk or a ring. Although telescopes had made significant progress in the 1920s, the observation possibilities were still in no way comparable to the technology we have available today. It was only with significantly better imaging that it became apparent that Andromeda is actually a spiral-armed galaxy, like our Milky Way. Only Andromeda is significantly larger. With a diameter of around 220,000 light-years, Andromeda is about twice as large as our Milky Way, which has a diameter of around 100,000 to 120,000 light-years. Although it's only slightly more than twice as large, it contains far more stars. The Andromeda Galaxy is estimated to be home to around 1 trillion stars, whereas we have just 100 to 400 billion stars in the Milky Way. Thanks to the higher star density, Andromeda is a true beacon in the night sky. Astronomers could only dream of such numbers and great details 100 years ago. Nevertheless, you can well imagine how exciting the discovery of other galaxies must have been back then. Today, we know for sure that there are around 50 billion galaxies. Estimates assume that there are a total of 100 to 200 billion galaxies in the observable universe. Some calculations even arrive at the astronomical figure of 2 trillion galaxies. The majority of these galaxies are found in a supercluster, which was named the Shapley Supercluster in honor of one of the first galaxy researchers. James Webb shows Andromeda as a ring of fire. It seems that every age and era has seen a revolution in science and technology. The telescope named after Edwin Hubble dramatically changed our view of the universe in the mid-1990s, and today, with James Webb, we have the best space telescope of all time. With razor-sharp infrared images, this telescope scans every light signal in the universe, no matter how small. Unlike Hubble, Webb detects traces of light in the infrared range. With its instruments, the telescope collects every trace of light, no matter how small, and assembles these minimal impulses into incredible images after hours of exposure time. Hubble already provided us with a powerful image of the Andromeda Galaxy. Imagine this image was assembled from thousands of individual images. Now, Webb is taking another look at the Andromeda Galaxy using unique infrared technology, and once again we are in for a surprise. Every new telescope and every technological advance introduces us to new areas of the universe. Infrared telescopy gives us insights that were unattainable with earlier technologies. One of the major improvements of infrared observations is the ability to reveal dust structures within galaxies. In the Andromeda Galaxy, for example, infrared light allows for the first time a clear view of dust rings that have remained hidden in other wavelengths. These dust rings tell the story of star formation within the galaxy and are evidence of the dynamic processes. Infrared observations are usually particularly useful for detecting cool objects that do not emit enough heat to produce waves in the visible light spectrum. This makes young stars and their formation regions particularly visible to Webb, and the telescope sees all the cool dust clouds that may eventually become stars, as Webb not only detects the dust, but also penetrates it without any problems. We can now see through the dense clouds of gas and dust, revealing the inner structures with active galactic centers and supermassive black holes. Creepy galactic cannibalism. While most of you have probably heard of galaxy mergers, where two galaxies become one, the fact of galactic cannibalism is probably a surprise. Galaxies eating each other sounds like a title from a bad science fiction movie, and yet this phenomenon is an astronomical reality. By cannibalism, galaxy researchers mean processes in which a larger galaxy literally devours the matter of a smaller one. In contrast to mergers, the larger galaxy extracts all the matter from the smaller one and destroys it. The basic structure of the larger of the two remains almost unchanged. This is triggered by gravitational processes. If galaxies come close enough to each other due to their mutual attraction and the difference in size is significant, this can lead to the disintegration of the smaller galaxy. This phenomenon has been observed particularly within galaxy clusters, where many galaxies lie together in a confined space. The gravitational interaction leads to a dynamic reaction in which stars, gas, and dust are pulled away from the smaller galaxy and incorporated into the larger one. The dynamic tidal forces can trigger enormous star formation phases and disrupt the nuclei of the galaxies involved. Are you surprised to hear that the magnificent Andromeda is one such galactic cannibal? Our neighboring galaxy has been shown to have devoured several of its satellite galaxies. Certain structures in the stellar population of Andromeda serve as evidence of these violent acts, and the traces are also visible, for example, in the galaxies M32 and M110, which are still partially visible today. Incidentally, our Milky Way is no innocent party in this cosmic drama. It has already assimilated several smaller galaxies in its history and is currently devouring the Sagittarius dwarf galaxy. Galactic cannibalism probably plays just as big a role in the development of galaxies and the shaping of the large-scale structure of the universe as harmonious marriages between galaxies or even encounters in which galaxies only partially touch and change each other. Due to the fascinating constant movements and interactions, the cosmic networks are constantly changing, and the cosmic networks in turn contribute in their own way to the dynamics of the galaxies. All in all, this is a cosmic round dance that we can only explore and understand in fractions. The most powerful crash of all time, Milkdromeda. It's true. At this very moment, the Andromeda Galaxy is hurtling towards us at a speed of 110 kilometers per second, and we are also moving towards it. The cosmic marriage of the two is inevitable, and it almost seems as if the two are magically attracted to each other. In around 4.5 billion years, the climax of the cosmic spectacle of superlatives will take place. The Milky Way and the Andromeda Galaxy will then begin their final merger. The result will be Milkdromeda, and the birth of this new galaxy will mark the end of two separate galactic entities. This coming together is not abrupt, but a process that will gradually gain intensity over millions of years. As the two get closer and closer, their respective gravitational fields will begin to interact with each other, leading to dramatic changes in the structure of both galaxies at a certain distance. First, the outer stars will collide. Their orbits will be perturbed by each other's gravitational forces, which can lead to a beautiful, albeit chaotic, arrangement of stars. Stars and star clusters that were once stable in their galactic disks will then be thrown into new orbits. Some will probably even be catapulted out of the galaxies and then travel through the vastness of intergalactic space without a connection to a galaxy. At the same time, gas and dust between the galaxies is compressed, leading to a new wave of star formation. A firework display of young, brightly shining stars will accompany this galactic wedding. Unlike cannibalism, the two are becoming increasingly intermingled. Some regions are merging harmoniously, while others are undergoing major changes under pressure. At the heart of the two galaxies, the drama becomes even more intense. The colossal central black holes approach each other, orbiting each other in an ever closer dance until they finally merge. This merger is accompanied by the release of massive amounts of energy, and huge jets can shoot out into the surrounding universe at almost the speed of light. During the hundreds of millions of years in which this merger takes place, the appearance of the resulting galaxy will change drastically several times. Voyager 1 is so far out in space that it is almost 6,000 times the average distance from the Earth to the Moon. More than 45 years have passed since the space probe set off on its iconic mission in 1977, and the probe and its identical twin, Voyager 2, have explored areas where no man-made object has gone before. Voyager 1 was the first human probe to reach Jupiter in March 1979. There it took the first detailed images of Jupiter's turbulent atmospheric patterns, including the Great Red Spot, and provided fascinating insights into the diversity and activity of its moons. Since then, we have known about volcanic eruptions on Io, and we had the first evidence of subsurface oceans on Europa. After the successful exploration of Jupiter, Voyager 1 flew on to Saturn. The probe mapped Saturn's impressive ring systems and discovered the fine structures within the rings. It also took the first close-up image of Titan, Saturn's largest moon, and revealed important data about its dense atmosphere, prompting scientific speculation about Earth-like fluid cycles on the moon. After these groundbreaking discoveries, Voyager 1 continued its journey past the outer planets on a path that would eventually take it out of the Sun's sphere of influence and into interstellar space. That was in 1980. The probe then flew through the Kuiper Belt for 10 years before finally reaching the magical threshold of open space after another 12 years. On August 25, 2012, Voyager 1 was clearly visible in interstellar space for the first time, and there were some surprises waiting for the researchers. Signals so strange they shouldn't exist. What was really going on when Voyager 1 measured a sudden stream of particles in interstellar space? Particle streams in open space should not actually be so close to our solar system. Scientists suspected that the stream could have originated from a distant event, such as a plasma ejection from a star. However, it would be highly unusual for such streams to travel so far into interstellar space and be carried so far by it. You must realize that the closest star to the location where the mysterious stream was measured is more than 4 light-years, or 37,842,921,890,333 kilometers away. A plasma ejection stream at this distance should have long since dispersed within the emptiness of the universe. Many scientists therefore doubt the theory and concede that we could be dealing with a mysterious, unknown force. Some daring scientists have even speculated that the particle stream could indicate activity from extraterrestrial life forms. Surprisingly, Voyager 1 showed that the overall particle distribution in space is much denser than previously thought. This may not sound very exciting at first, but in astrophysics, just a few particles can change our entire picture of the universe. One of the most striking features of interstellar space is the significant increase in cosmic rays. As expected, Voyager 1 recorded a significant increase in the intensity of cosmic rays. This observation provided important information about the composition and dynamics of space beyond our heliosphere for the very first time in human history. The data from Voyager 1 also indicate that the interstellar magnetic field is stronger and has a slightly different orientation than expected. These findings are not only forcing scientists to rethink their models of the interstellar medium and the interaction between the solar wind and the interstellar medium, we may have to rethink the entire math of our galaxy. The magnetic fields in the interstellar medium play a crucial role in the dynamics of galaxy assembly and star formation. Some theories even suggest that the magnetic fields could also be remnants of a primordial magnetic field that emerged shortly after the Big Bang. These original fields could therefore still be magically effective primordial structures that carry the developmental processes of the entire universe within them and are therefore messengers of cosmic history. Why is Voyager 1 so long-lived? It was a memorable day in human history. When a Titan 3E Centaur rocket launched Voyager 1 into space on September 5, 1977, no one thought it would be more than 45 years in the future. At the time, the scientists wanted to take advantage of a unique conjunction of the outer planets, which only occurs every 176 years, to send the Voyager probes to the then still largely unknown planets. The first target was the gas giant Jupiter. Voyager 1 arrived there a little earlier, although it was launched later than its sister. This was because Voyager 1 had taken the more direct, but also more dangerous course through the asteroid belt between Mars and Jupiter, while Voyager 2 was accelerated along slightly different orbits. Both Voyagers also stopped by at Saturn, after which they parted ways. While Voyager 1 set a direct course for the end of our solar system, Voyager 2 delivered the very first images of the planets Uranus and Neptune. The scientific and technical successes of the probes in the 1980s were already overwhelming. The fact that Voyager 1 is still functioning and transmitting scientific data well over 45 years after its launch is nothing short of a miracle. The Voyager mission was an open-ended adventure. At the time, NASA was already planning a further flight into the Kuiper Belt and possibly even further, but whether the probes would actually arrive was written in the stars. The fact that both probes reached open space is an iconic achievement, and they could continue to deliver important data for some time. If something hadn't happened, that scared NASA. Is Voyager 1 about to end? It was the nightmare no one wanted to experience. In the middle of one of the most exciting phases of the mission, Voyager 1 reported a disaster. In May 2021, it looked as if Voyager 1 had completely lost its orientation in space. But then, the engineers noticed that although the probe's signal was going crazy, it was surprisingly consistent. If Voyager 1 were tumbling around in space, the signal would arrive with interruptions because the probe's antenna must always be pointed strictly towards Earth in order to transmit the signal over the long distance. If the signal arrives, the antenna must also be correctly aligned, and consequently the position of the probe in space must still be stable. So where did the crazy telemetry data come from? For weeks there was confusion. Signals were coming in, but they made no sense. The mood at NASA was one of crisis. Dozens of engineers set to work, studying old construction plans from the 1970s, bringing long-retired technical staff out of retirement, and finally a solution was found. Telemetry data is essential for monitoring and controlling spacecraft, as it provides information on the status and health of the various systems and instruments on board. An analysis showed that the faulty telemetry data came from the attitude, articulation, and control system, which is responsible for pointing the spacecraft in space. As the antenna was correctly aligned, the program of the control system must have somehow got mixed up. It was agreed that the AACS may have started sending telemetry data over a path or channel not intended for it, which then led to the illogical data. The challenge was to fix the problem from billions of kilometers away. One wrong instruction could have made the problem worse and rendered the probe useless forever. The team worked feverishly to find a solution and decided to reroute the internal controls to an alternative system to see if it would work again from there. As you can imagine, the tension was high. The order was sent from the control center in California. Engineers had to wait 20 tense hours for Voyager's response. Then came the relief. The plan had been a complete success and Voyager was sending usable data again. Then came another shock in the fall of 2023. Once again, confused data arrived at the control center in California. Of course, the incident was immediately reminiscent of the problems from 2021, but something was different. The communication disruption occurred for the first time on November 14, 2023. Instead of normal radio contact, the probe transmitted a meaningless, repetitive sequence of zeros and ones. NASA suspects a malfunction in the Flight Data System, FDS, which is responsible for collecting and transmitting data from the scientific instruments and status information from the probe. Experts have been tasked with deciphering the cryptic data. It was hoped that the data could be used to draw conclusions about the error, and they succeeded. An engineer from the D-Space network, over which Voyager 1's signals are transmitted, discovered that the jumble of ones and zeros was an exact replica of the probe's FDS memory. So Voyager 1 was still alive, only the data was acting up again. Despite the glitch, the probe was able to receive and execute commands from Earth, further indicating that not all communications capability was affected. At the time of the video's release, the problems still persist. Due to the long distances and software limitations, diagnosing and repairing the problem is again complicated. So far, there is uncertainty as to how the fault could be fixed this time. In NASA's latest statement, the head of the Voyager project, Suzanne Dodd, was not very hopeful. NASA is expecting the mission to end prematurely. NASA is currently gloomy about the chances of restoring the probe's ability to communicate, but Suzanne Dodd emphasized that the team has not yet given up completely and will try other solutions. But then the probe suddenly started transmitting again, and the first signal from Voyager 2 after the communication breakdown came as a surprise. This probe has now traveled more than 18 billion kilometers and is invaluable to science. Losing Voyager 2 at this delicate point in the mission would be a tragedy. What had actually happened? Why had this probe, which had been traveling in space for more than 45 years, suddenly lost radio contact? In July 2023, panic broke out at NASA's Communications Center. Voyager 2 had gone silent. Those responsible were shocked. Voyager 2 had simply lost radio contact following an erroneous command that changed its antenna orientation. During a routine check, NASA's control team had inadvertently sent an erroneous command to Voyager 2, causing the spacecraft to turn its communications antenna away from Earth. Given the enormous distance of over 18 billion kilometers, correcting this error was a monumental challenge. Each signal from Earth took more than 17 hours to reach the probe, and it took just as long for a response to arrive back on Earth. Days went by without a signal being received, adding to the concern. A permanent loss of communication with Voyager 2 would not only have meant the loss of a historic mission, but also the loss of an invaluable source of data about interstellar space. In a last-ditch effort to re-establish communications, the NASA team sent a series of commands in the hope that Voyager 2 would receive one of them and respond accordingly. It was a race against time, as the probe's power supply and ability to receive commands diminished with each passing day. At the same time, every day that this probe sends data from space is valuable to the scientists. The sweating and worrying continued into August 2023. Some scientists had already given up hope, and NASA had to seriously consider publicly announcing the loss of the probe. Then the unbelievable happened. Voyager 2 responded again. The signal was weak but unmistakable, and was a clear sign that the probe had received the command and carried it out correctly. The relief and joy in the control center were boundless. The NASA team had achieved the seemingly impossible. Communication had been re-established with one of the most distant man-made objects in the universe. This meant that Voyager 2 had also successfully overcome a crisis. In 2022, after more than 45 years, the sister probe Voyager 1 found itself in an awkward situation. The telemetry data was no longer correct, and for a few days it seemed as if the probe had lost its orientation in space. But here too, NASA showed itself to be in control. After weeks of troubleshooting, those responsible discovered a fault in the onboard computer. Here too, the engineers delivered a brilliant performance. Similar to Voyager 2, they sent an instruction over 20 billion kilometers. The probe changed the onboard computer system, and after hours of hoping, a response finally came back. How long these two veterans of space exploration will continue to send data is unclear. However, the scientists hope to be able to maintain contact with both Voyagers until around 2030. Then they will disappear forever into the depths of space, and radio contact will be lost due to a lack of power. Voyager 2 at the magical threshold of the heliosphere. The scientists had imagined everything in detail. For decades, there were concrete ideas of what it would look like at the end of our solar system. Computer simulations calculated everything precisely, and then the surprise happened. On November 5th, 2018, Voyager 2 approached the magic boundary of the solar system. The researchers noticed that the probe was unerringly approaching this threshold by, among other things, a change in the ambient radiation and particle density. No one had ever seen this threshold, and no probe had ever been there before. What would Voyager 2 find there, billions of kilometers from Earth? Naturally, the researchers hoped that the probe would confirm their data and calculations. But then came the disappointment. Voyager 2 reported completely unexpected data. This repeated the unpleasant truth for the scientists, as Voyager 1, the twin probe, had already traveled across this distant threshold in 2012 and had transmitted similar data. Neither probe confirmed the researchers' assumptions. The heliosphere does not end gently like a beach, but more like a wall or an invisible bulwark. That was surprising. Ever since Voyager 1 had sent this data, there had been confusion. Had the probe perhaps traveled across the threshold at a particular point that was structured differently? No, after Voyager 2 transmitted almost exactly the same impressions and measurement data, it was clear that the sill of the solar bubble is quite solid and bumpy everywhere. This groundbreaking discovery once again proved to our scientific community that we can't know anything for sure until we, or probes, have been there. It confirmed once again that we know very little about the universe for sure, and that theories are just theories, not truths. Our universe is unimaginably large and contains countless phenomena, objects, structures, and peculiarities, very few of which we can visit or examine on site. We have to rely on model calculations and hypotheses, and these are often wrong, as the Voyagers proved once again. The day Voyager 2 flew over the threshold of the heliosphere was another moment when a piece of the puzzle fell into place in our cosmological worldview. Now, knowing for sure how our solar sphere ends brings more clarity, but also new questions. Just the question of how the hard threshold at the end of the solar bubble is formed will keep researchers busy for several years. Scientists spontaneously explain this with the interaction between the solar wind and the interstellar medium. Presumably, the pressure of the interstellar space causes streams of particles to pile up at the edge of the solar sphere, which then form an almost solid threshold or a dense outer skin. However, this means that the interstellar medium has a different structure than we previously thought, and the probes actually delivered surprising measurement data here too. There are far more particles in interstellar space than previously assumed. You can imagine the heliosphere as a huge bubble. This bubble is formed and maintained by the constant solar wind. The sun envelops itself and its planets in this protective balloon of particles. The main difference between the heliosphere and interstellar space is its density and temperature. At the outer edge of this sphere, the two media meet and an interaction occurs. This outer edge is the heliopause, and it extends between 10 and 20 billion kilometers from the sun. In total, the heliosphere has a diameter of around 30 billion kilometers. This structure in which we live is not static. The entire sphere travels as a closed unit through the galaxy and the universe. The solar system is located in one of the outer spiral arms of the Milky Way. We are probably moving through the galaxy here in our bubble at 828,000 kilometers per hour, and our galaxy is moving through the universe at around 2.1 million kilometers per hour. 1977 was perfect for the start. At the beginning of the 1970s, a researcher happened to recognize a special constellation of planets and had an idea. Soon the outer planets would be lined up as perfectly as they are every 176 years. During their orbits around the Sun, Jupiter, Saturn, Uranus, and Neptune could be in completely different quadrants of the system. But during this constellation, all four should be almost in a row close to each other, so that a probe could easily reach all four planets. The constellation also brought the planets so close to Earth that the flight time to Neptune was a whole 12 years shorter. NASA had to seize this opportunity. Two simple and almost identical probes were constructed in a rush. Voyager 1 and 2 got by on a minimal budget and were launched at record speed. On August 20th, 1977 and September 5th, 1977, Voyager 1 and 2 were launched on board Titan Centaur rockets on their iconic journey into space. Little did anyone know at the time that more than 45 years later, these two probes would still be flying through space, breaking record after record. After passing Jupiter and Saturn, Voyager 2 used the gravitational pull of the two planets to perform a gravitational maneuver that took it to Uranus and Neptune. For the first time, humans saw bright blue Uranus in all its beauty, and Voyager 2 photographed deep blue Neptune in all its splendor for the first time. In addition to the images, Voyager 2 provided groundbreaking measurement data. The probe showed the wafer-thin rings around Uranus for the first time, photographed the most violent storms in the solar system on Neptune, and discovered previously unknown moons of the two ice giants. These were historic moments for science and humanity. When will Voyager 2 reach the nearest star? Voyager 2 will travel through complete darkness for another 40,000 years or so. Then a light will appear again for the first time. It will probably be Ross 248. Computer calculations have shown that the probe's course will take it directly there, but it's unclear whether the probe will be captured by this system. The probe is probably too small and too light to enter the sphere of another star. Voyager 2 will therefore remain in the interstellar medium and fly on, until after thousands of years the next star passes by. Nobody knows how long these probes will continue their journey through space. They may simply break apart at some point, or they may still be flying millions of years from now. We humans are optimists. Just in case there is life out there in space somewhere, we have attached a calling card of our civilization to the two Voyagers. Should aliens ever get their hands on the probes, they will find two golden records and a simple set of instructions inside. Designers and scientists have created the records and the mechanism in such a way that any technologized species should be able to play the discs. Now, We don't know who or what is out there in space. The disks could also end up in a world where there are only animals or plants. They could fall into a corrosive ocean of acid somewhere or fall into the hands of a species that doesn't know what to do with the disks. Less optimistic people even fear that our well-intentioned greetings could end up in the hands of predatory aliens in outer space. Become a subscriber now and be part of every new video highlight.